In this lesson, we're going to look at a second client against Amazon's e-commerce service, and the working document you're looking at is called Amazon2 code1.txt. It's included in the working files, and it summarizes the similarities and differences between the two clients. So let me start with the similarities. The second client, like the first, can be invoked from the command line. So in this case, it's java-jar, amazon2.jar, and as command line arguments, your access ID and your secret key. Amazon2.jar contains all of the relevant files, including, for convenience, the source code. The second client, like the first, does a so-called item lookup. It provides the numeric key, in this case for a book, a Harry Potter book, that Amazon has in stock, and Amazon responds with an XML document that summarizes all of the relevant details about that book. And the first client, we used a so-called DOM parse, tree-based parse, to extract relevant information from the XML document. In this case, we're going to avoid the parse altogether and rely instead on JAX-B technology. So let me go over the details before we look at the actual code. The B in JAX-B stands for binding, and basically what this does is it provides a correspondence between XML data types and Java data types. Here are the details. Amazon publishes an XML schema for its e-commerce service. It's quite a beast, as you can see there, 1,300 lines of XML, and I have the cursor positioned on the URL. For convenience, I've downloaded that document and put it on my local disk, and you'll see why in just a minute. Now, this XML schema fully describes the layout of the response documents that we get back from the Amazon e-commerce service. In programmers' terms, the XML schema provides data types, so this is extremely important. Core Java comes with an XJC utility. It's a conversion utility. It converts XML, in particular an XML schema, into Java data types. That utility, by the way, is in your install directory in the bin subdirectory, so the same place as the compiler and the runtime. The way it works diagrammatically is this. You feed an XML schema document to XJC, and then XJC generates the corresponding Java classes, which of course are Java data types. At this point, what you have is XML on the one side, the XML schema, and Java on the other side, class files. So it's quite powerful and convenient. By the way, in this particular case, you wind up with a lot of classes, about 85. So let me show you with the command line how this works. To begin, I'm in a bash shell, by the way. You can see amazon.xsd. That's the XML schema that I downloaded locally. And now what I'm going to do is run the XJC utility. The -p stands for package. XJC is going to create a subdirectory called pack-A. Any name would be just fine. And it's going to populate that with the Java classes that correspond to Amazon's XML schema. So here we go. Now let me just show you what this subdirectory looks like. As you can see, we have all sorts of Java source files, and let me highlight one of them just for emphasis. So you see, for example, there is a source file called item.java, and that represents a particular item such as a book or a CD and so on. We're not actually going to look at these files. They're heavily annotated. We don't care about the details so much. We care about how they're going to be used.